You know, when we talk about the biggest, the biggest unfinished business in physics, it really feels like a breakup.
A bad one. A century-long divorce, really.
Exactly. The divorce between general relativity and quantum mechanics.
Right. You've got general relativity on one side, and it handles all the big stuff perfectly. Gravity, planets, the shape of the universe.
And on the other side, you have quantum mechanics, which is just flawless for the tiny stuff. Particles, atoms.
They both work. That's the maddening part. But you try to get them in the same room, mathematically
The
speaking,
whole thing just explodes.
the equations just give you nonsense. Infinities. It's a total mess.
So for decades, the hunt has been on for a mediator, a theory of everything. We've had string theory, loop quantum gravity.
All trying to patch things up.
But today, we're looking at something that comes at it from a totally different direction. It's a manuscript called the Aetheron Model by Aaron Buscemi.
And it proposes something called, and this is a mouthful, Supersymmetric Geometric Quantum Mechanics, SGQM.
SGQM. Okay, so
Right.
what's the big idea?
Well, the core idea is, it's surprisingly elegant. It basically says the reason we can't unite everything is because we're thinking about reality all wrong.
How so?
We think of it as stuff particles sitting in an empty box called space. But Kadimi says, no, reality isn't made of stuff, it's made of geometry.
Living geometry.
Living, rotating geometry. And the origin story for this isn't some dry equation.
No, this is what got me. It starts with him as a 6-year-old kid lying in bed.
And doing that thing we've all done,
Yeah.
pressing your thumbs into your eyes.
Right. You see those little flashes of light, the spirals and checkerboards.
Phosphenes, yeah. Most of us just think it's, biological noise.
But he saw something else. He called it the blackboard of nothingness, and he was convinced he was looking at the actual blueprints of the universe.
Which sounds, it sounds almost mystical.
It does, but then he takes that vision and builds a rigorous 12-dimensional mathematical model from it. So let's start there. What is this Aetheron?
Okay, so it's not a particle,
Yeah.
and it's not really a field like the magnetic field.
So what is it?
Think of it as the stage itself, but a stage that's alive and has its own rules. The model says space-time isn't an empty container. It's a generative 12-dimensional manifold.
Okay, hold on. 12-dimensional manifold, that's usually where you lose me.
I know.
We live in 3 dimensions, right? Up, down, left, right, forward, back, plus time. That's 4. Where are the other 8?
That's the key. They're not curled up super small, like in string theory.
So they're not hiding somewhere.
No. In SGQM, you have our 4 dimensions, what he calls M4, that's our home. But at every single point in that space, there's an internal 8-dimensional structure.
Inside the point.
Exactly. He calls it the fiber, F8. Imagine a thick piece of rope. From far away, it's just a 1D line.
Sure.
You zoom in, and you see it's made of smaller threads, all twisted together. That twist, that internal structure, that's where the other dimensions are.
So a particle like an electron isn't a thing in space?
It is a thing that space is doing. It's a specific kind of twist in that internal 8-dimensional rope.
And this is where it gets really interesting, because that means matter and forces.
Are the same thing. They're
Yeah.
just different projections of that internal spin.
Which brings us to the math. And I have to say, I laughed when I saw the core equation, because it's literally a triangle.
It is. It's the Pythagorean theorem.
My 10th grade geometry homework. A squared plus B squared equals C squared.
That's the one. But here, the sides of the triangle are the fundamental components of reality. The equation is alpha squared equals mu squared plus E-rot squared.
Okay, let's break that down. We have a right angle triangle. What's the long side? The hypotenuse.
The hypotenuse is alpha. In physics, that's the fine structure constant. But here, it represents the total geometric budget of the Aetheron. It's a constant. It cannot change.
The budget is fixed. Okay, so what are the other 2 sides?
One side is mu. That's the mass term. That's your matter, your fermions, the stuff we're made of.
And the other side?
Is E-rot, rotational energy. That's your forces. Light, bosons, all that.
And because it's a right triangle, they are at 90 degrees to each other. They're orthogonal.
Exactly. Now think about the implication. If you have a ladder against a wall, that's your fixed hypotenuse.
And I pull the bottom of the ladder away from the wall.
The top has to slide down.
So if I increase the mass side, the energy side has to decrease to keep the hypotenuse the same length.
Instantaneously.
Hmm.
And that, he argues, is supersymmetry. Not new, undiscovered particles, but this geometric trade-off. You can't change one without the other.
It's a zero-sum game of geometry.
Pretty much. And this structure, this triangle, It also explains one of the absolute weirdest things in quantum mechanics.
Go on?
If I spin you around 360 degrees in a chair, you're back where you started, right?
A little dizzy, but yeah, facing the same way.
An electron isn't. You have to spin an electron 720 degrees, 2 full turns, to get it back to its original state.
That makes no sense. A circle is 360 degrees. How can you have a 720-degree circle?
It sounds impossible. But there's a classic demo for this, the waiter's tray trick.
Okay, walk me through it. I'll try right now.
All right. Hold your hand out flat, palm up, like you're holding a tray.
Okay.
Now rotate it 360 degrees by passing it under your armpit, keeping it flat.
Whoa, okay. I did it. My palm is up again, but my whole arm is twisted. This hurts.
Exactly. You've rotated 360 degrees, but your structure, your arm, is not back to its original state. It's stressed.
So I have to keep going.
You have to do another 360, up and over your head this time, to untwist your arm. That's 720 degrees to get back to true north.
So the electron is twisted after one turn.
And SGQM says the reason why is that a fermion isn't one thing spinning. It's a dual boson structure.
Meaning?
It's 2 different rotations happening at the same time on 2 different axes.
Ah, so when one part has done a full 360, the other one is only halfway through its own cycle.
In a sense, yeah. The model says the geometric projection, that little triangle, literally flips over horizontally, then vertically.
And that flipping creates handedness, like being left-handed or right-handed.
Exactly like that. And that, he argues, is the geometric difference between matter and antimatter.
So antimatter isn't some exotic, evil twin. It's just the triangle flipped the other way.
A mirror image in that 8-dimensional fiber. And to get the whole system topologically stable, you need a massive 1440-degree metacycle.
4 full turns.
4 full turns. He argues it's the only way to conserve everything: charge, parity, and time.
It's like seeing the tiny little gears inside a Swiss watch.
Oh.
But speaking of things that break your brain, we have to talk about the part of this that really stopped me.
I think I know where you're going.
The non-propagation hypothesis.
The claim that light doesn't travel.
Right. Light doesn't travel. I'm looking at a lamp right now. Physics 101 says photons are flying from that bulb to my eye at the speed of light. What does this model say is happening?
It says nothing is flying. Think about a giant TV screen in Times Square. You see a car drive across it.
Okay.
Is anything actually moving?
No. The
Yeah.
pixels are just turning on and off in sequence.
The pixels stay put. They just update their state. The model argues the Aetheron is the screen. A photon isn't a little bullet. It's a coordinated ripple of updates in the lattice.
One point of geometry rotates, which makes the next one rotate, and so on, like dominoes.
Precisely.
So the speed of light, see, it's not a cosmic speed limit.
It's the refresh rate. It's the processing speed of the universe. The maximum rate at which the geometry can pass that rotational information from one point to the next.
That actually makes more intuitive sense to me. I've always wondered why that specific speed. But if it's the clock speed of the hardware, that's a hard limit.
It reframes everything, and it links back to our triangle.
With mass and energy being at 90 degrees.
Right. Now think about a light wave. It's an electromagnetic wave. You have an electric field and a magnetic field. How are they oriented to each other?
Perpendicular at 90 degrees.
There you go. The model says that's not a coincidence. The light wave is just the 4D shadow of those 2 internal vectors rotating. One acts as a sine wave, one as a cosine wave, because the geometry forces them to be orthogonal.
It's very consistent, I'll give it that. But if light doesn't travel, what about gravity?
Gravity is definitely not a force in SGQM. There's no graviton particle.
So what's pulling me down into my chair?
It's an emergent geometric response. It's the energy cost of keeping the lattice synchronized.
Explain that.
Okay, so you have this perfect, orderly grid, the Aetheron. Then you drop a huge mass in it, like the Earth.
Which is a giant concentrated knot of internal rotation.
Exactly. That massive knot twists and strains the geometry around it. The surrounding lattice has to work. It has to expend energy just to maintain its synchronization.
And that tension is what we feel as gravity.
That's the idea. It's a fabric of reality trying to snap back into a lower energy state. And he even claims to derive Einstein's equations from this. You know, the famous 8 pi in those equations?
It's just a constant, right? Makes the math work.
Here, he says that 8 pi is literally the 1440-degree cycle required for stability. 4 full turns is 8 pi radians. It's not just a number, it's the geometry itself.
Wow. But he also challenges Einstein on one specific thing, Mercury.
Yes, the troublemaker. Mercury's orbit shifts in a weird way, and Einstein's theory predicted it perfectly.
So is Buscemi saying Einstein was wrong?
Not wrong, but maybe incomplete. SGQM proposes something called magnetic leakage.
Which sounds like magnetism is interfering with gravity.
It is. In that 8-dimensional fiber, the axis for magnetism, R6, is right next to the axis for gravity, R7.
Okay.
The theory argues that because the sun's magnetic field is so enormous, it actually creates a tiny torsional drag on Mercury's orbit. The magnetic rotation leaks over and affects the gravity rotation.
And that would be a new testable prediction.
It would. It makes the theory falsifiable. If we can measure a deviation that matches this magnetic drag, it's huge evidence.
That's the key. But speaking of unexplained things, let's talk about the biggest ghost in the universe, dark matter.
The 85% of matter that we can't see or touch.
Right. Standard physics just kind of shrugs and says maybe it's some invisible particle. What does FGQM say?
It calls them dark bosons. And the explanation is actually one of my favorite parts of the whole model. It's so clean.
Go on.
Remember the two groups of internal axes, R1 to R4 for matter, R5 to R8 for forces.
Got it.
Buscemi proposes you can tie a knot in the geometry using only the force axes, R5 through R8.
And not made entirely of force.
Exactly. But here's the clever part. The axis for electric charge is R2.
Which is in the other group, the matter group.
So if you tie a knot using only the force axis, you completely bypass the charge axis.
It has no electric charge, so it can't interact with light. It's invisible.
Electromagnetically silent. But it still uses axis R7, the curvature axis.
So it still has mass, it still has gravity.
It has gravity but no light, which is literally the definition of dark matter.
And that's why we can't detect it. Our instruments all use electromagnetism.
Right. It's like it's running on a different part of the universe's operating system.
This is a lot. We've gone from a kid seeing patterns in his eyelids to a universe where dark matter is a knot of pure force.
It's a sweeping vision. And it even tries to explain the fundamental constants, pi, the golden ratio, alpha.
Which we usually just accept as that's just how it is.
The model claims they are geometric necessities. The gears have to be that size to mesh.
One last thing before we wrap. Entanglement. Spooky action at a distance. How does that work if nothing can travel faster than the refresh rate?
It uses the higher dimensions. The model calls it rotational memory.
Okay.
The idea is that entangled particles aren't two separate things. Here in our 4D space, they look far apart. But in the full 12-dimensional manifold, they're part of the same continuous geometric knot.
They're still touching.
In the higher dimensions, yes, they're part of the same object. So when you measure one, you're not sending a signal. You're just shifting the whole object at once.
It deletes the paradox by deleting the distance.
It's a bold move, but it's consistent.
So to sum this all up, we have a theory that says reality isn't stuff in a void.
It's a living geometry, constantly buzzing and updating itself.
It tries to replace the spookiness of quantum mechanics with, well, with structure.
Exactly. And it leads to a really final, profound thought about something as basic as inertia, Newton's first law.
An object in motion stays in motion. We think of it as passive resistance, stubbornness.
But SGQM frames it as the persistence of rotational coherence. Inertia is an active process. An object keeps its state because its internal geometry is furiously working to maintain that shape. It's the universe's memory.
That is a beautiful and slightly terrifying thought, because if the universe could forget, if that coherence slipped for just a moment.
The solid ground beneath your feet wouldn't just crumble. It might just stop being matter at all.
Or maybe what feels solid to us is just a 12-dimensional shape spinning incredibly fast.
That's the question, isn't it?
On that note, I think I need to go sit down. Thanks for taking us through this.
My pleasure.
And thank you for joining us on this deep dive. We'll see you next time.